So only those two harmonics will pass through. Okay? And then they will have their respective phases. You can figure out what the phases are at the two things. And then you can figure out the zero state response of this system. Okay, let me see. Part 2. So only n is equal to 3 and 5 would go through, and then you can write the zero state response t as being just picking up the first harmonics and then multiply by the product of amplitude and phase. Okay? The n is equal to 1 harmonic, you put n is equal to 1 over there. N is equal to 3, okay? Sorry, n is equal to 3 harmonics, you put n equals 3 over here, and then you put in the cosinusoidal function, put in the right frequency, put n is equal to 3 here, minus pi over 2, and then figure out the phase. The phase for 3 pi over 6 is that you can work out the formula for the phase. This phase formula is that 1 over 4 pi omega. Okay, this phase formula is given by that. It's a straight line that has a negative slope. So when omega equals to 3 pi over 6, you can figure out what the phase is and just add in the phase. 1 over 4 pi, 3 pi over 6 for the first term. And then you pick up the n equal to 5 harmonics. Okay, write that down. It becomes 1 over 5 pi cosine of 5 pi over 6t minus pi over 2. And then let omega be 5 pi over 6 in this formula and figure out what the phase should be. Okay, so it should be 1 over 4 pi, 5 pi over 6. Okay, so this is the zero state response of the system. And then you are asked to find P of y, the power that is in the output. Okay, P of y, according to Passavier's theorem, is C0 over 2 squared plus n is equal to 1 to infinity Cn squared over 2. But is there a DC term to this response? Is there a DC term? No, right? So we only pick out the 3 and the 5 terms from here. You pick out the 3 and the 5 terms from here, you have 1/3 squared, and the amplitudes are 1/3, okay? Okay, I'm sorry, there's a pi somewhere that I'm missing. There's a pi here. Okay, according to this, there's a pi here, and there's a pi that multiplies this thing as a result, the pi that multiplies this thing. So this is just 1/3. This in total becomes 1/3, this in total becomes 1/5. Okay, I was missing a pi over here. It comes from the bandpass filter. So the power will be this one plus 1/5 squared over 2. And then you can work this out. And if you're good with it, and everything works out correctly, with no problem, this is the answer. I don't know, this is actually 17, right? Over 225. Okay? This is part A. I still have part B to do. Okay, this is a long problem. Part B. Let me try to do part B. Part B, part 1, you're given that ft is equal to e to the t, or minus t, u of t minus 1. Okay, find this Fourier transform. So to find this Fourier transform, you just do the direct integration f of t e to the minus j omega t dt. Okay? And then you need to only integrate from t equal to 1 because u of t minus 1 looks something like this. This is 1, this is t. So you only need to integrate from 1 to infinity. So you integrate this from 1 to infinity, but plug in the value of f of t, which is e to the minus t, e to the minus j omega t dt. And this should give you e to the minus 1 plus j omega over 1 plus j omega as you integrate that. And there's another way of doing it, which I would not go through. Okay? And then part 2 is that you're given that gt is equal to 1 over 1 plus j t minus 1 plus 1 over 1 minus j t minus 1 is equal. Find the Fourier transform of this. We know that we can use the symmetry formula that f of t, when it's given by e to the minus t ut, Fourier transform to f of omega, which is equal to 1 over 1 plus j omega. Okay, we know this, and then by the symmetry formula, f of t must Fourier transform to 2 pi f of minus omega. Okay? By using this property, then you can figure out that 1 plus jt must Fourier transform to 2 pi e to the omega u of minus omega. Okay? And then by the same token, you can figure out that there's the error in the solution here. Actually, it should be 1 over j minus jt, the solution to omega. 1 minus jt should Fourier transform to 2 pi e to the minus omega u omega. Okay? Then you combine the two, then 1 plus 1 jt plus 1 over 1 minus jt Fourier transform to the sum of these two. Okay, sum of these two is just equal to 2 pi e to the omega, right? Minus omega. It just gives you that. Okay, when you combine these two, you get that. But then the answer is actually 1 plus j t minus 1 plus 1 over 1 plus j, or 1 minus j t minus 1. Then you have to use the phase relationship, and then 2 pi, it should be something like this. Okay? This should be 2 pi e to the minus j omega 1, okay? Omega 1 times e to the minus omega. Okay, so this should be the answer. Slightly different from what is given here, but just combining them into one formula as is in the solution. Are there any questions? Okay, I have 5 minutes left. So what should I do with the 5 minutes? Are there any questions that you may have? Okay, if there are no questions, I'll let you go. Okay, we'll lecture again tomorrow at 1 p.m.